Let us discuss first OSI versus TCP/IP. We already have discussed about the OSI model in detail in previous lecture. So OSI is a conceptual model used for network communication. It is not implemented entirely, but it is still referenced today. On the other hand, TCP/IP is fully based on practical implementation, which make internet possible. This OSI model consists of 7 layers, and each layer is connected to each other. The data moves down the OSI model, and each layer adds additional information. The data moves down until it reaches the last layer of the OSI model. When the data is received at the last layer of the OSI model, then the data is transmitted over the network. Once the data is reached on the other side, then the process will get reversed. TCP/IP has 4 layers, where the first application layer includes first 3 layers of OSI model, and the fourth layer includes last 2 layers of OSI model. You can see the diagram that is shown over here. The TCP model stands for Transmission Control Protocol, whereas IP stands for Internet Protocol, a number of protocols that make the Internet possible comes under the TCP/IP model. This model consists of 4 layers. Now we will look at the diagrammatic representation of the TCP/IP model. Let us discuss about the application layer of TCP/IP model. It is a topmost layer which is equivalent to application presentation and session layer of OSI model. It acts as an interface between the application programs and has the same capable features of application presentation and session layer of OSI model. It uses protocol like SMTP, HTTP, HTTPS, FTP, NTP, SSH, Telnet, SNMP, etc. All work on this layer. In this layer, data act as a protocol data unit. In short, it is normally known as PDU. Let us now discuss about the transport layer. It is also known as host to host layer. We have already discussed about the application layer. Application layer is used by the end user, and after the application layer, transport layer plays its vital and significant role. It is equivalent to the transport layer of the OSI model and is responsible for delivering the data. It depends on which type of protocol is used, whether it is transmission control protocol, that is TCP, or user datagram protocol, that is UDP. It decides which types of protocol that will be used for this transport layer for transmission purpose of the data packets. If reliable delivery of data is needed, then it will use the TCP. TCP will be used for reliable transmission of data. UDP is used if fast delivery is required without much more reliability. So UDP is used if fast delivery without reliability is needed. In this layer, TCP and UDP, the protocols which are used, and data acts as a protocol data unit. This is normally in short known as PDU. Now we will be discussing about the internet layer. It is equivalent to the network layer of the OSI model. Logical addressing and routing is performed at this layer by using the IP addresses of the device. At this layer, the routers forward the packets on the basis of IP addresses of devices. IP is the most important protocol at this layer. The protocols used at this layer are Internet Control Message Protocol. In short, it is known as ICMP, and Internet Group Management Protocol. It is known in short IGMP. PDU at this layer is packet. We already have discussed about the internet layer, which is equivalent to the network layer of the OSI model, where the destination and the source IP addresses are added to the data packet to find the exact route for the routing process and to find the exact intended network for reaching the packet to the end destination. And now we are going to discuss about the network access layer. It is equivalent to the data link layer and the physical layer of the OSI model. Hardware addressing is done at this layer. It defines protocols for physical transmission of data. Ethernet is the most important protocol used at this layer. Fast Ethernet, token ring, and fiber distributed data interface, in short it is known as FDDI, are other protocol at this layer. PDU at this layer is called frame, and normally the end device within the same network are being identified as the MAC address. MAC addresses are the unique identity for each and every devices, which can be found ultimately in the network for receiving the intended data packet.